Good afternoon, ladies and gentlemen. Here is a summary for lesson 9 of unit 1. In this lesson, we did basic transformations on parallel lines. Okay, today's goals are we can describe the effects of a rigid transformation on a pair of parallel lines. Remember, rigid transformations means rotations, translations, and reflections. Okay, and then the last thing, if I have a pair of vertical angles and know the measure of one of them, I can find the measure of the other. So we're introducing this term called vertical angles. All right. Okay, and then here we started with a set of parallel lines. So we have the blue lines are the original ones, and then we did the translations. So here we did translation up 3 units to the right 2, which puts it right there. So there you have A prime, and then B, same thing, up 3 units, 1, 2, 3, to the right 2, and then the key here is when we did these translations, you see that these two lines are parallel, and then the images are also parallel. They are the same distance away from each other. So notice they're 1 unit away from each other right here. And the new ones, the images are also 1 unit away from each other. Okay, and here we have the similar idea here with a rotation. So line A here is rotated. We did 180 degrees around center K. And then B and B prime, when we did that rotation, stayed in the same position. And then again, you notice that the lines that are parallel are still parallel, and they are parallel to each other. Okay, and the third one that we did these two lines were reflected across line H. Here is the reflection, and again, notice they're parallel in the original. And when we did the reflection, they are still parallel. They remain parallel, and they are 1 unit away from each other, 1 unit away from each other. Nothing changed there. So the idea here is with all three of these transformations, parallel lines went to parallel lines. If the lines start parallel, then they end parallel. All right? When we perform rigid transformations on parallel lines, what do we know about the image? The image will be of parallel lines. That's what we saw in all three of them. They were parallel lines. Okay, and then now here we have these two sets that we did. We rotated these around 180 degrees around the center C. So notice here we did AD, rotated 180 degrees, and we got this one here. And we did this rotation here, and this angle here, and we did 180 degrees, and notice that they landed right on top of the lines there. Same thing here. These landed exactly on the line, and they're going the same direction. And the idea here is that these angles are the same. How does a rotation affect the measurement of the angles? It doesn't affect it at all. So here, this angle right here is the same as this angle right here, because when you do a rotation, the angles stay the same. So doing this rotation does not change the angle. Same thing here. This angle right here, when we did the rotation over here, made this angle, the angle stays the same. So these two are similar to each other. And on here, these are called vertical angles. All right. When we rigid transformations, when we do that, we can see that they retain their original line properties. So if they were parallel, they stay parallel. If they have an angle, the angle stays the same measurement.